All right, Business Calculus 13.1, we're going to be learning the integrals today, which is the reverse of the derivatives. Going back in our last chapters when we took the derivative, let's say I took the derivative of 3x to the fifth. That would become 5 times 3, so there was the 15. Drop your exponent 1, so there's the 4. So that, again, that was the 15x to the fourth dx. But see, when I go backwards, let's say I ask you to integrate the 15x to the fourth dx. So if we integrate that, 15x to the fourth dx, I'm asking you the derivative of what would equal that equation. So before we multiplied and then we subtracted, we are now going to do the reverse, remember? So we had our orders was we did multiplying and then we subtracted. So if we're going to go in the reverse from the exponent, and we subtract 1 from the exponent, if we're going to reverse this, we're going to add 1 to our exponent, and we will now divide by that new number. So I'm going to add 1 to this exponent, and that becomes 5. I divide by the new exponent of 5. Now I'll explain the plus c here in just a minute. This then simplifies. The 15 over 5 became the 3x to the fifth, which was that original derivative we were doing in the first place. Now, the plus c is because if this was a plus 1 or a plus 2 or minus a million, any number that you want to put there, see the derivative of any constant is 0. So if I took the derivative of this answer here, that would go back to this 15x to the fourth because the derivative of every single constant would be 0. So again, for your basic rules, okay, for taking a derivative, you will multiply those and then subtract 1. But when we're integrating, we're going to add first and then divide by that new exponent. And that's going to be your basic rule. Now we have a special case today though. Our special case is going to be if I'm asked to integrate x to the negative 1 dx. What happens then? All right, well if we add 1 to that exponent, I'm going to get x to the 0, divide by 0, and plus c. But can you ever divide by 0? No, you're never allowed to divide by 0. So this is not a possibility. Let's go back to our last chapter when we took the derivative of the natural log of u. The derivative of the natural log of u, that was du over u. That was du over u. So if I'm asked to integrate x to the negative 1, aren't I really being asked to integrate 1 over x? And then that was times the dx out here. So again, this was x to the negative 1. Okay, that's 1 over x. So I'm really here being asked to integrate dx over x. Well, think about that. We've already done the derivative of the natural log of u was du over u. So if I'm going backwards and integrate du over u, that's going to give me the natural log of u. Well, then this answer right here, the integral of 1 over x dx, really the integral of du over u, will be the natural log of your u, but you do have to do the absolute value of it, and then plus c again. So that'll be your new rule today that you are going to need to get memorized, is that the integral of, let me write that on here, the integral of du over u is going to be the natural log of u plus c. So we're going to need to have that memorized today. All right, along with, you're also going to need to memorize the integral of e to the u du will also be e to the u plus c also. And again, that was from our last chapter. Remember, if we took the derivative of the e to the u, it equaled e to the u du. So it's just the reverse. Again, the integral and the derivatives are just going the reverse of each other. So make these two into flashcards. I'm going to pull up the homework papers here in just a second to give you guys some pointers on those. All right. So on number 2, it asked us to integrate 18 to the x. So what you just need to remember is that you're going to add 1 to that exponent. That was an exponent of a 1. So therefore, that's now an exponent of a 2 and divided by that 2. And that's how I got the answer of 9x squared plus 2. All right. The next one was to integrate the constant of 2. Well, if you think about that as integrating the 2x to the 0, where that exponent is a 0. Add 1 to that exponent, that would give you 1. Divide by that new exponent of 1. Therefore, that simplifies to 2x plus c. All right, number 4. Integrating 14x plus 6. So again, I'm going to add 1 to my exponent. Right now, this is 14x to the 1. So when I add 1 to it, it's 2 and divide by 2. The derivative of what is 6? Well, that would be 6x. Or I can think of that as 6x to the 0. Add 1 to it, it's x to the 1, divide by the 1, plus c, and then simplify the expression. So 7x squared plus 6x plus c. All right, number 5. Integrating 3x squared minus 3x plus 4. So again, remember, add 1 to each exponent. So I'm going to bring this out a little bit. All right, so when I add 1 to that, that's going to be 3, and I divide by the 3. That is 3x to the 1, so I add 1 to its 2 and divide by the 2. This is just plus 4, x to the 0, really. So that's x to the 1 and divide by the 1. And then we simplify our answer to that. All right. Number 6 would be just like number 5 was, so I'm going to go ahead and skip number 6 with you right now. Okay, I'm going to jump to number 7. When you see one like this, you would want to rewrite that. See, this is the integral of 15 square root of y. So when I rewrite that, that's going to be the integral of 15y to the 1/2 dy. Now I can add 1 to that exponent. Adding 1 to it becomes 3/2 divided by that new exponent of 3/2. Now this is 15 divided by 3/2. Remember, that would just mean 15 times 2/3. And 15 times 2/3 would become 10, y to the 3/2 plus c. Alrighty. Again, on number 8, I would do another rewrite because I see square root of x. See, I would want to rewrite that as 10x to the half plus, and then I would leave that square root of 5 actually, x to the 0. So I rewrote it as 10x to the 1/2, left it as the square root of 5 as my coefficient, and x to the 0. So when I add 1 to this exponent, that 1/2 becomes 3/2. Add 1 to this exponent becomes 1. And remember to divide by those new exponents. So there's my x to the 3/2 divided by 3/2. So that becomes 10 times 2/3, which is where I got the 20/3. This becomes, that was x to the 0, so x to the 1 divided by 1. That's just say square root of 5x, and then my plus my c. All right, I'm going to skip number 9. We're going to jump to number 10. Number 10, I had to integrate 2 over x to the 6 dx. So again, we'd want to rewrite that first as 2x to the negative 6 dx. When I add 1 to that exponent, it becomes negative 5 and divide by the new exponent. There's my plus c. Remember, anything raised to a negative power would bounce down to the bottom, and a positive 2 divided by a negative 5 would become that negative 2/5, and there's my x to the 5th plus c. All right, number 11. Integrating 8 times e to the 9x. We know how to integrate e to the u du. So I would have to let this u equal my 9x. So u equals the 9x. My du is 9dx. Now that means that I'm going to have to multiply and divide by 9. Because see, I don't have 9 in this expression to give me my du. So what happens is I factored out this 8 to the front. I know I need to have a 9 times in here, so I also had to divide by 9 to actually keep this to the same expression as the original. Now this 9 and this dx happen to be my du, and that right there is my e to the u. So I end up with a coefficient of 8/9, the integral, so here it is, 8/9, the integral of e to the u du. Now when I integrate that, I'm going to end up with 8/9 e to the u plus c. Plug back in for this u, which was 9x, and there's my final answer. If you're not quite following the multiplying and the dividing by 9, you might need to see me and have me explain it to you using some different colors. Sometimes that's really helpful in learning how to do that. All right, so let's look at number 12. We'll have another example like that. We have 4e to the negative 0.5x dx. So again, I can integrate e to the u du. So that means this is probably going to have to be my u right there, the negative 0.5x. So I let that equal the u. The du is the negative 0.5 dx. I don't need the 4. I'm going to factor that 4 out. But I do need is the negative 0.5. So if I have to multiply by negative 0.5, I have to divide by it to keep this to the equivalent expression of the original problem we're working with. Now this right here, the 4 over negative 1/2 becomes negative 8. And then this is my du and e to the u. So if I have negative 8 integral e to the u du, that just becomes negative 8 e to the u plus c. Plug back in for your u, and there's your final answer. Be careful with number 13, because number 13 is going to kind of be using 2 different rules at the same time. All right, so what's going to happen on this one? We have 3 over x, Then I have plus 2e to this complicated stuff, basically. See, I got to think of that one as an integral by itself first, because that's just really 3 times like dx over x. That's really like 3 du over u. This one, on the other hand, would definitely be a u substitution, where my u is going to have to be the negative 25/100ths of x. So what I ended up doing in teaching in your write-up for your homework, I rewrote the integral of the 3 over x dx by itself, took out the 3 coefficient, so it's the integral of dx over x. So that's now 3 natural log of x plus c. Then I took care of the integral of the second part. Again, the 2 is just the coefficient, so that's just stuck out front. I see that I probably need that exponent to be my u, so there's my u, negative 0.25x. So the du would be negative 25/100ths dx. Again, I need that negative 25/100ths multiplied by this, so divided by it. That's where that came from, right there on the bottom. So this became 3 over negative 25/100ths, integral of e to the u du. Therefore, that right there simplifies to negative 8, and that is just e to the u plus c. Plug back in for your u. Now remember, my final answer, I was really integrating these two terms separately, so I just have to add those two together. And you only write plus c once. If you're adding one constant to another constant, you still just get a constant. Okay, so number 14. Now on number 14, okay, come on, I'm waiting for the camera to view. There it goes. We have a monomial in the denominator. And anytime you have a monomial in the denominator, it is best if you go ahead and divide that into each term separately. So that's what I've done here. I've wrote 1 over the 3t plus the 2t to the 5th over the 3t. All right, in the first case, that becomes just 1 over 3, and then that's dt over t. See, that will integrate to the natural log of t, written right there. All right, on the second term, this became 2/3, but then that's t to the 4th dt. T to the 4th, you add 1 to that power, divide by that new power of 5. Therefore, that became 2/15 t to the 5th plus c. When you see one like number 15, you should FOIL this out first. Once you FOIL that out, then it should be very simple to integrate. So there's your FOIL it out. You're going to add 1 to that power. That's where this 3 came from, and divided by it. Add 1 to that power, so 2, divide by it. That's 25x to the 0, so add 1 to its power would be 1 over 1, and plus c again, simplify the expression. Now, the next 3 are a little bit too long for me to do them on here on this video, but what you need to understand is that they are giving you the derivative function already. So you have to integrate, and after you integrate, they are giving you a point on the curve. So you will need to plug in the -1 for the x and then set the equation equal to -2 so you can find what the plus c is. So in other words, you're actually going to find what the c value is for these next ones, because they're telling you here what a point that the graph actually passes through. So it can't just be some arbitrary plus c this time. So if you look at my handouts that I wrote up and I posted online for 16, 17, and 18, I think you'll be fine with those. And the same for number 19 as well. And I wish you guys the best of luck. We'll see you tomorrow.